Hey, hello. Right now, I am going to discuss about Venn diagram and give you about some details about it.
So alright, we have a problem here. There are 40 students, 14 are taking philosophy and 29 are taking psychology. Our problem, if 5 students are taking both classes, how many are taking philosophy only? So in here we need to begin at the very center of the Venn diagram. So since 5 students are taking both classes, which is common here, we need to write down 5. In order to solve on how many are taking philosophy only, we need to subtract 5 to 14 and 29. So 14 minus 5 is equal to 9. 9 people are taking philosophy only. So we're gonna write here down 9 and 5, subtract 5 to 29, that will be 29 minus 5 is 24. So 24 students are taking only philosophy.
Hi, and good day to everyone. And my name is Ronald. Today, I'm going to explain about the topic number theory.
Number theory refers to the integer and its property. It also studies the basic principles of divisibility, greatest common denominator, LCM, and modular arithmetics. Now, the first problem. The last digit should be even, meaning, example A, 110, the last digit is 0, so it satisfies the condition the last digit should be even, so okay. 79, the last digit is 9, so no. C, 36, yes. 24, the last digit is even. The second problem, the second digit must be an odd number. A, it does not satisfy the condition, so X. 36, X also. 70, X also. 59, yes, it satisfies the condition. Third problem, the sum of digits is divisible by 4. So 381. We're going to add 381 and get this. 3 plus 8 plus 1 is equal to 12. And 12 is divisible by 4. That results into 3. So check. 217. 2 plus 1 plus 7 is equal to 10. 10 divided by 4 pertains into something that is not divisible by 4. So X. 202. 2 plus 0 plus 2 is equal to 4. 4 is divisible by 4, so it satisfies the condition, so yes. Problem number 4. The first 2 digits must be divisible by 3. Problem A. 1312. So only 13. 13 divided by 3, X, does not satisfy the condition. Problem number 2. 3017. First, the 2 digits is 30. Divided by 3 will get 10. So, yes, it's divisible by 3. Third problem. 6308. So 63. And it can be divided by 3, so yes. Problem number 5. The sum of the first and last digit should be an odd number. So we're going to add 1 plus 4. That results into 5. So an odd. Check. Problem number 2. 6301. The first digit is 6, the last digit 1, results into 7, so check. Third problem, 8,276, 8, the first digit, and 6, the last digit. That results into an even number. So it does not satisfy the condition, so X. The sixth and last problem. The sum of the first and third digit should be a multiple of 2. So the first sample would be 6,329. The first digit should be 3 plus 2. That results into 8. And 8 is a multiple by 2. 2 times 4 equal to 8. So check. Second sample. 7,013. First digit will be 7 plus 1. That results also into 8. Same as the first. Third sample. 7,715. 7, the first digit, and 1 as the third digit. So 8. So it satisfies the condition, so check.
Hi, I'm Lorraine Cueto, and I'm here to teach you about permutation of discrete math. Example of permutation. How many ways can 13 knights be seated in a round table? The formula is quite simple. Just this. Your n is 13. 13 knights are to be seated at the round table. All you have to do is put the value of n here and minus it to 1, an exclamation point. And now, there. And according to our calculator, the answer is 479001600. These are the numbers that can, these are the ways that 13 knights can be seated in different seats at the round table. Number 2. Number 2. Number 1. Number 2. There are 4 persons sitting in a line, in a row. How many possible ways it can be arranged? Our n is 4 and our r is 4. The formula for this is n exclamation point over r minus n. N and exclamation point. Just substitute the value. N is 4 over r. R is 4 minus n exclamation point. Cancel this out. Only remaining is 4 exclamation point, and the answer is 24. The other solution for this is by doing this process. 4 times 3 times 2 times 1 is also equals to 24. These two are just the same. So the answer is 24 on question number 2.
Villena. So now I'm going to teach you about. So what is combination? Combination, it is the number of different ways that a certain number of objects as a group can be selected from a larger set of objects. It is denoted by NCR, which means n choose r. So the formula is n factorial over r factorial times n minus r factorial. So let me give some examples of how to get the combination of a certain problem. So The problem is how many committee of 4 members can be formed from 10 engineers. So first, you have to determine the total number of the given, which is n is equals to 10, and r, you have to determine the r, which is 4 members. So n is 10 and r is 4. N is 10 and r is 4. So you have to just substitute the values of n, which is 10 factorial over 4 factorial, which is the r, and n minus r, which is 10 minus 4 factorial, which is equal to 10 factorial times 6 factorial times 4 factorial. So 10 factorial over 4 times 6 factorial is so these are some examples of how to get the combinations of a given problem. The problem is how many committee of 4 members can be formed from 10 engineers. So you have to determine the total number, which is n, and it is 10 engineers, and the committee of 4 numbers, which is the r. So you just have to substitute the values of your n and r to the formula. So the n factorial is 10, which is going to be on the numerator, and 4 factorial in the numerator times 10 minus 4 factorial. Then its equivalent is 10 factorial over 4 factorial and times 6 factorial. So the equivalent of 10 factorial is 3,628,800, and the equivalent of 4 factorial times 6 factorial is 720 times 24. So 720 times 24 is 17,280. So you just have to divide the values of numerator from the value of the denominator, which is 3,628,800. So 3,628,800 divided by 17,280 is 210. So therefore, there are 210 ways of 4 members can be formed from 10 This is the second example of how to get the combination of a given problem. Given a set of 7 letters, and which is A, B, C, D, E, F, G, how many combinations of 3 are there? 3 combinations. So just like what we did in last example, you just have to determine the total number, which is 7, and the r, which is 3. So again, you have to substitute the values of n and r. So the value of n is 7 factorial, and the value of r is 3 factorial. So 7 factorial over 3 factorial times 7 minus 3 factorial. So its equivalent is of 7 factorial is 5,040, and the equivalent of 3 factorial times 4 factorial is 144. So again, you just have to divide the numerator to the denominator, which is 5,040 over 144 ways, in which now you can get the combinations that you can form from 7 letters in just 3 letters, which is 35 combinations of 3 letters can be formed in 7 letters.
I teach you how to do the binomial coefficient. I'm gonna teach you now.
First,
Right
we're gonna
now.
go to the Pascal triangle. Let's do the Pascal triangle.
Just the first layer is level 1. Second layer is 2 up to 5th level. And
Okay. Binomial coefficient. This is the problem number 1. A plus B to the power of 4. So we will distribute the 4 in A and B. So this is the format. A raised to 4 and B is raised to 0, because the K is equal to 0. So it's a constant that the K is 0. Then A3 B1. So in A raised to 4, the 4 will minus 1, and the result is 3. And you will add 1 in the 0 that goes of
1, and a minus a raised to 2 b raised to 2 plus a raised to 1 b to b raised to 3, and a raised to 0 b raised to 4. Then we will cancel the 0, and this will the outcome. A raised to 4 plus a raised to 3b plus a raised to 2 b raised to 2 plus a b raised to 3 and plus 4 plus b raised to 4. And by the Pascal triangle, this is will the outcome of the problem. A raised to 4 plus 4 a raised to 3b plus 6 a raised to 2 b raised to 2 plus 4a raised to 3 b raised to 3 and plus 1b raised to 4. Or you can cancel out the 1, that a raised to 4 plus 4a raised to 3b plus 6 a raised to b raised to 2 and b raised to 2 plus 4a b raised to 3 plus b raised to 4. That's all. Thank you.